The final stages of the evolution of massive stars, when a star's core completely burns out, reaching iron, energy production stops, and the core begins to collapse rapidly. During this process, electrons and protons are compressed together, forming neutrons and neutrinos. While neutrinos easily escape the core, neutrons reach an incredibly dense state equivalent to an atomic nucleus. They occupy the smallest possible space, akin to the formation of white dwarfs, but neutron stars are much denser than any object we can see in the universe, second only to black holes. Imagine an immense mass squeezed into a tiny area, roughly within a diameter of 20 kilometers, resulting in the weight of a teaspoon of neutron star matter being unbelievably heavy. Let's pause before discussing what would happen if a teaspoon of neutron star material came to Earth and clarify what's in our spoon. As mentioned earlier, we're talking about an incredibly dense ball of neutrons. The reason the neutrons within neutron stars, remnants of massive stars at least 10 times more massive than our Sun, don't collapse further is due to a phenomenon called neutron degeneracy pressure, where two neutrons cannot occupy the same space simultaneously. As the star loses mass, only about 1.5 times our Sun's mass remains, but this mass collapses to an area of around 16 kilometers. Under normal circumstances, a star of this mass would be expected to have a diameter of 1.6 million kilometers. If we were to take a teaspoon of mass from our Sun, using the same method as before, it would weigh about 2 kilograms, roughly the weight of a standard laptop. However, if this were a neutron star, and we took a teaspoon of it, we'd be talking about roughly 1 billion tons, equivalent to the weight of Mount Everest. In essence, while a teaspoon could lift our Sun, it couldn't handle a teaspoon of a neutron star. From a weight perspective, placing a teaspoon of a neutron star on Earth's surface wouldn't make much difference. There would be no discernible change in its orbit or gravitational force. It would be akin to adding another large mountain to our planet. Considering gravitational effects, if we ponder how the local gravitational pull of a mountain-sized mass affects things, the difference here would be so small that humans wouldn't feel it unless you held the teaspoon. However, our primary concern wouldn't be the mass in our teaspoon. Neutron stars are incredibly dense and hot due to immense mass compressed into a tiny space. If we brought this teaspoon to Earth, the mass remaining around the neutron star and its associated gravitational pull would vanish. Inside a neutron star, neutron degeneracy pressure battles against gravity, and in the absence of surrounding gravitational mass, this pressure wins. Here's an analogy. Imagine you have a fizzy drink, and you've shaken it quite vigorously. You know that the pressure inside will be released and it will burst when you open the cap. Similarly, by bringing a teaspoon of neutron star material to Earth and eliminating the surrounding gravitational pull, the pressure inside the neutron star would rapidly release and expand. A teaspoon-sized neutron star suddenly appearing on Earth's surface would cause an enormous explosion, vaporizing a significant portion of our planet. So, if you ever have the chance to visit a neutron star in the future, it's advisable not to bring it back with you to Earth. And before we finish, don't forget to subscribe to my YouTube channel and turn on notifications to catch more content like this. Until next time, take care.